Let's stop and think for a minute about what really happens when a solid melts or a liquid boils. We are not breaking any bonds during these physical changes. Instead, we're using heat energy to overcome intermolecular forces and physically separate the molecules from one another. All phase changes have a heat flow associated with them. Some of these phase changes, like melting and evaporating, are endothermic, while others, like freezing and condensation, are exothermic. Phase changes that increase molecular contact are exothermic. This harkens back to the same principle that we discussed with lattice energy and covalent bond formation. That is, attraction, whether it's between particles, ions, atoms, or in this case molecules, reduces energy. Exothermic phase changes, therefore, include freezing, condensing, and deposition, that is, going directly from the gas phase to the solid phase without passing through the liquid. The opposites of these processes, that is, melting, evaporating, and subliming, are endothermic processes. When a phase change occurs at constant pressure, the heat flow associated with the phase change is equal to delta H for that phase change. We'll look at specific enthalpies of phase change in class.